Hi, everyone. I'm expecting you to review 0.11 and 0.12 on my website, but let's do a quick overview. 0.11 is on solving equations. Now, when we talk about solving an equation in X, say, we were looking for all real solutions that will make the equation true. And when we solve an equation, the answer to a solve an equation problem is given by a solution set, the set of all solutions. So for example, if you're asked to solve the equation 2x equals 6, there's only one real solution to that, x equals 3. Well, 3 is the sole solution. Our solution set consists of the sole number 3. We can check it out if we want. Plug in 3 for x, and it checks out, 6 equals 6. Now, if you have an equation like x equals x plus 1, well, there are no real numbers that equal themselves plus 1, so the solution set is the empty or null set. That happens sometimes. On the other hand, if you have something like x plus 1 equals x plus 1, all real numbers work out for x, so the solution set is R, the set of all real numbers, which you can also write in interval form like this, the set of all real numbers. This is called an identity, by the way. Now, before, in the earlier parts of chapter 0, we talked about simplifying an expression. For example, if I told you to simplify the expression 2x plus x, your answer might be 3x. On the other hand, if I tell you to solve the equation 2x plus x equals 3x, I'm asking you, what are all the real values for x for which the left side will equal the right side? Well, all real numbers. Our answer to a solve an equation problem is a solution set, which here is R. So remember, there's a difference between simplifying an expression, in which case we'd say 2x plus x is 3x, and solving an equation, in which case we'd say the solution set to this equation is R. So far, we've been looking at linear equations, where we didn't have x squared or x cubed or anything like that. Well, how do we solve quadratic equations? Equations that can be written in the form ax squared plus bx plus c equals 0, where a is non-zero and a, b, and c are real coefficients. Well, we can use the quadratic formula, given famously by this. X equals the opposite of b, plus or minus the square root of this thing, the discriminant, b squared minus 4ac, and that's all over 2a, all over 2a. Please don't do this. Make your fraction nice and long there. So for example, we could use the quadratic formula to solve this quadratic equation. But in order to prep this equation, we need what on the right-hand side? We need a 0 there. So we have to subtract 15 from both sides. When you subtract 15 from both sides, then you get this equation where we have 0 on either the left or the right side. And then we can apply the quadratic formula. All right. We should identify the coefficients. A equals 2. B equals 7. Sorry, B equals negative 7. It's easy to mistake signs. That's why it's good to write these out. And C equals negative 15. Not positive 15, which might have confused people up here. C is negative 15 because you have to look at the form where 0 is isolated on one side. And then when you plug in, notice that the discriminant, 169, is a nice perfect square. We end up with rational solutions, negative 3/2 and 5. The solution set consists of those numbers. Separate by commas, put braces. We take both the plus case and the minus case. Now, because the discriminant was a nice perfect square, we could have used the factoring method. The zero factor property helps a lot. If I have two quantities that multiply to 0, then that means at least one of them has to be 0. That's the zero factor property. Again, we need to isolate 0 on the right side, or one of the sides, because we have a zero factor property, not a 15 factor property. For example, 3 times 5 could be 15. Over here, we can factor this cutie, like so. Set each factor equal to 0, solve, and we get the same two solutions. By the way, it doesn't matter what order you put the solutions in. All right. So because the discriminant was a nice perfect square, 169, we got rational numbers as our solutions. If the discriminant is 0, meaning we have a PST here, we just have one double root. If the discriminant's negative, we have two imaginary solutions. That's for later. The square root method. If you're solving something like x squared equals 3, then the solutions will be given by plus or minus the square root of 3. Don't forget the plus or minus. Now, if you have something like x squared equals negative 3, well, remember, squares of real numbers are never negative. This cannot happen. Solution set is the empty set. So using the square root method, if there's no x term, solve for x squared. You get x squared equals 4/3. Use the square root method. Plus or minus the square root of 4/3. Simplify that radical. Rationalize the denominator. Here we multiply by root 3 over root 3. And we get our solution set. Although quite frankly, if you end up with this here, that might be more convenient, but technically our solution set should be written like this. The completeness square method can also work, especially if A is 1 and B is even. It can work pretty nicely, so you can look that over. When solving rational equations, for example, 9 over x cubed equals 1 over 4x, you might want to look for the LCD, the least common denominator. X cubed and 4x, in a way the smallest thing they both divide into nicely is 4x cubed, the LCD. Both x cubed and x go nicely into x cubed. We can multiply both sides by 4x cubed with the understanding that we can do that as long as x is not 0. We end up with x equals plus or minus 6. Neither one of these is 0, so these are both legal. These tentative solutions are in fact true solutions. This is our solution set. If we had gotten x equals 0, we'd have to reject it because we cannot divide by 0. That's a check. When you're solving radical equations, remember that if you start with x equals 2 and you square both sides and get x squared equals 4, remember that that equation actually had two solutions, 2 and negative 2, that worked for x. So these were not equivalent equations. Equivalent equations have the same solution set. These are not equivalent. This is why when you do things like square both sides of an equation, you have to check at the end. So for example, if you're solving this square root equation, we start by squaring both sides, and we get a nice polynomial equation. We end up with x squared equals 25. The square root method, we get x equals plus or minus 5. But wait a minute. Because we squared both sides of an equation up here, we have to check. Plug 5 into the original equation before you got your dirty hands all over it. The 5 works out. Nothing bad happens. 3 equals 3. But if you try to plug in the negative 5, wait a minute. You're trying to take the square root of negative 1. That's no good. We must reject the negative 5. I realize that root negative 1 equals root negative 1 might look good, but we don't allow that. If you try to take the square root of any negative number in a check, you're dead. You have to reject that tentative solution. The solution set is that. Only consists of the sole solution 5. In absolute value equations, well, depends on the situation. If the absolute value of x is 3, what are the only two numbers whose absolute value is x? plus or minus 3. What are the real values whose absolute value is negative 3? Well, hold on. Absolute values are never negative. The solution set here is the empty set for this over here. So when you're solving an absolute value equation, like this over here, be prepared for a couple of cases. The absolute value of blah equals 2. That's a non-negative number, so we have 2 cases that can work out. If that were a negative 2, we'd be dead. Empty set. So in one case, we let x minus 1 be positive 2. In the other case, we let x minus 1 be negative 2. We solve both equations. We get 3 and negative 1, and they form our solution set. Now remember, the absolute value of x minus 1 can also be interpreted as the distance between x and 1. So we want all real values of x whose distance from 1 is 2. Well, what 2 numbers are 2 units away from 1 on the real number line? Here's 1. 3 is 2 units to the right. Negative 1 is 2 units to the left. And they form our solution set.